Hello, everyone, and welcome back to Invitation to Puzzles. Today we have a quadruples puzzle. So this is a sudoku variant that I wish we actually saw more often than we do. We don't see it that terribly often, but I think it is quite enjoyable. So I'll explain to you how it works. So what we have sort of scattered around the grid are these circles. These are the quadruples with some digits in them. And it might be one digit like this 2, or it might be three digits or 4 digits, however many it is. And what these do is they tell us something about the digits that appear in the surrounding 4 cells. So for example, this 6 tells me one of these digits is a 6. This 2 tells me one of these is a 2. This actually tells me one of these is a 7 and one of them is an 8. Likewise, this one tells me one of these is a 7, one of them is an 8, and one of them is a 9. So that is how quadruples work. Remember, as usual, we need to place every digit from 1 through 9 in every row, column, and 3 by 3 box, so exactly once. Alrighty, those are the rules of the puzzle. So good luck, give it a try. There's a link in the description. And in case you get stuck or want to see me do it, I will be here to hopefully rescue you, because hopefully I can solve this puzzle. But good luck. All right, so the name quadruple makes some sense, because actually if you fill in all 4 digits, then you actually know these 4 digits are the digits 1, 2, 3, 4. They can't be anything else. And likewise, these are 1, 2, 3, 5, and they can't be anything else. But actually over here in this box, if you look closely, that actually already gives us something. Namely, one of these 4 digits is a 1, but we know the 1 in this box is in one of these 4 digits because it's a quadruple. It's 1, 1, 1, 2, and 1, 3, and 1, 5. That means together, this has to be the 1. I can't put the 1 anywhere else. If I put the 1 up here, this quadruple is lying. And if I put the 1 here, oh boy, we've got all sorts of problems. And if I put the 1 somewhere like here, if you're wondering, that breaks this because now I've got 3 digits from 1, 2, 3, 4, 5. Or if you prefer, this quadruple has told me that 1 is up here and it isn't. So this 1 gets placed like that. Now notice that's less useful, or less immediately useful, you might say, if you instead have only a handful of digits, then you sort of don't get quite as much. I do think it's probably worth marking what these digits are. And so I'll show you 2 ways. I like doing sort of things where there's sort of 2 ways to see it. Let me show you the 2 ways of thinking about this step. So one of them is to just say, okay, so these numbers are 5, 6, 7, 8, 9. And these numbers are 4, 6, 7, 8, 9. And so here's way 1 to think about this. Way 1 is to say these 6 cells are a sextuple. Namely, what is a sextuple? It's one we don't see super often. You have to write down 6 digits. So in this case, the 6 digits I'm writing down are 4, 5, 6, 7, 8, and 9. And those 6 digits have to appear in exactly these 6 cells. So these 6 cells, the 6 I've highlighted in yellow within row 3, they all are from 4, 5, 6, 7, 8, and 9, which means they are 4, 5, 6, 7, 8, and 9. And so these 3 digits, they can't be 4, 5, 6, 7, 8, or 9, because I need 6 spots for those 6 digits, and they're these 6. And so these digits are the other ones, namely they're 1, 2, 3. Okay. That's way 1 of thinking about this. The other way of thinking about this, and a good trick to keep in mind, is that you can actually notice that these 2 quadruples have 1 in common. And so they form what I usually call a Zackwing, after the channel mascot, Zach, who is here. Namely, these 2 things, they both have a 1, which means that when I ask where 1 goes in row 3, well, it can't go in box 3, and it can't go in box 1, so it's sort of pushed over here into box 2. Likewise, when I think about twos, the 2 here can't be in here in row 3. It can't be here in row 3, so it goes here in row 3. And the 3, again, because of these things both having it in common, it gets pushed over here as well. Okay. And so any commonalities between two opposite quadruples get sort of pushed around into various places. So that doesn't happen too often in this puzzle, but it does happen in some places, and it happens in a lot of quadruples puzzles. Okay, and I want to point out that has the same impact as our sextuple did. Namely, I now know that these digits have to be 1, 2, and 3 exactly. And so I can actually write 1, 2, 3 right into these because I need to fit the 1, the 2, and the 3 into these cells. So if you want sort of a different way to think about why these cells have to be a 1, 2, 3 triple, that's a different way of doing it. And we can actually update our pencil marks just slightly. Namely, this one can't be a 2 because we have a 2 quadruple over here. Okay, that has had an immediate impact on our 6, 7, 8, 9 quadruples, though. Namely, that cell can't be 6, 7, or 8. And so if I'm going to fit 6, 7, and 8 in these 3 cells, I have to do it like that. And if I'm going to fit 7, 8, and 9 in these cells, I have to do it like that. And that, funnily enough, those quadruples have given us a Sudoku quadruple in row 4. Namely, these digits have to be exactly 6, 7, and 8, 6, 7, 8, and 9 once each. I'll highlight those in yellow real quick. That's not yellow. I'll highlight those in yellow real quick. Now, it's important to remember when you have a quadruple like this, that it doesn't just give you eliminations in the pencil marks. It also gives you some sort of implicit or explicit corner marks. Namely, one of these cells definitely is 9, because they have to be the 4 digits 6, 7, 8, and 9 in some order, and it's not these. So it's one of these. One of these is 9. What that tells me is that this digit isn't 9. And that might take you a second to think about, because this is not usually how this deduction shows up. It shows up in a lot of different ways in Sudoku, but usually not sort of bent around a corner like this. But if this digit was 9, it means I've put 2 9s around this quadruple. That's, on the surface, fine, because the rules of quadruples don't tell me I can't put 2 9s around the quadruple. But it's actually not fine, because then I've put 2 9s around here, but I've also put a 1, 3. And if I put 2 9s and a 1, 3, that means I've only got one space left for the 7 and the 8, and that doesn't work. So basically, these 3 digits are a bizarre triple. They're an actual 7, 8, 9 triple, so one of those is a 9, so this can't be a 9. And likewise, I know one of these two is a 6. So this can't be a 6, because if it was, again, that would be 2 6s around this quadruple, and I'd run out of cells before I got the 7 and the 8. Okay, so that can be worth thinking about. And that's actually bought me a few things. One thing it's bought me is it's bought me a 7, 8 pair in row 3. And so these 4 cells, sorry, these are a 4, 5, 6, and 9, if you wanted to keep that in mind. Now, one of the tricky things in quadruples puzzles is scanning, because you have to pay attention and notice things, one of which you might have noticed as I was explaining all of that before, but I'll start with another one so you can still be typing your comment about how I haven't seen it yet, which is, we know the 4 in this box is up here, so these can't be a 4. We know the 5 in this box is up here, so these can't be a 5. And so you can actually corner mark. There's a 5 here and a 4 over here in the same way. Now, there's a way, way, way more useful one that you can actually notice, which is that this 7, 8 quadruple tells me this cell can't be a 7 or an 8. So in fact, that's a 9. Okay, so we actually have all of that sort of laid out for us now. Uh, let's see. I don't see any more sort of leaping out. So let's look at this box. I know one of these is a 2. But I also know, because of this 4 quadruple, one of these is a 4. I need to put the 4 around here somewhere, and that somewhere is definitely in row 2. So these digits can't be 4, it looks over, which does a lot of nice things. So one of the things it does is to say this is a 2-3 pair now, so these aren't 2 or 3. But that 2-3 pair also looks over here and tells me that this digit is just a 5. Which actually makes those a 2-3 pair. Okay. So what am I doing with that, actually? One presumes we have to do something with it. Let's see. Well, that's not a 9 for what it's worth. Okay, so I see something complicated. I'm checking to see if I see something less complicated before I show you the complicated thing. This isn't the complicated thing, but I see that I can place a 9 over here on this quadruple. Because I know there needs to be one, so it's over there. I also see that, remember, I know one of these 2 is 6. I also know one of these 4 is 6. I don't know which one. But the key thing here is that this is actually an example of the aligning digits and quadruples that we saw before, albeit it's a slightly more subtle one. But this actually tells me I actually know where the 2 6s in columns 3 and 4 are, roughly. One of them is here, one of them is here. So I can't put any more 6s in columns 3 and 4. That is the Zach wing pattern that I mentioned before. And that's useful because it tells me these digits can't be a 6. Well, where does that actually put the 6? That actually puts the 6 over here. So in fact, there's a way easier way to see this. So in fact, I'll show you this way, and then I'll show you the way that I think I probably intended to do this when I made the puzzle. One of these 2 is a 6, so these 2 are actually going to be a 5-6 pair. Okay, here's the easier way. The 9 looks into box 3 and actually guarantees that one of these is a 9. And so that actually makes these a 4-9 pair by the way that our corner marks upgrade to center marks. Again, having the 4 and the 9 here in the corner means that the 4 and the 9 in this box go in these 2 cells, but that means I can't put anything else in these 2 cells. So when you have your overlapping corner marks, they upgrade to center marks, which means we get an honest 4-9 pair over here, which then makes these a 6-9 pair. So anyway, you could have done that either direction, but that is what we get here, is that these are 4-9. And so we actually know what this triple is now. This triple is actually 7-8, and the other one, which is 2, 3, 4, 5, is 6. And these are actually 7-8, and the other one, which in this case is 5. Oh, and we even know where the 5 is in this particular instance. Namely, we seem to know that the 5 is there. What did I do? Because I broke the puzzle. The puzzle is broken because I am now claiming that the 5 goes in one of these cells, which does not seem to be true. Oh, I see. I understand what I did. The thing that I did was, when I filled these in, and I had a corner marked 5 over here and everything, and I went to remove the 9, I didn't actually remove the 9, I removed the 5 instead, which then led to disaster, as you just watched. Sometimes you get to rewind and it's all okay. Sometimes it turns out you made some disastrous error earlier. Okay, so let's do this again. So these are 7, 8, and the other one in this case is a 6. And these are 7, 8, and the other one in this case is a 9. Oops, I believe. So I think this is a 7, 8, 9. I think this is a 6, 7, 8. Hopefully that's not broken. Okay. So that gives me 2, 6, 7, 8, 9 quadruples in each of these columns. So we can actually go ahead and fill in that these are not from 6, 7, 8, 9, and these are not from 6, 7, 8, 9. Which is going to be helpful because it now means that these two cells aren't the 6, 8. So these two cells have to be the 6, 8. But even in this instance, we know what order they go in because the 6 in this box is not here. So that's the 8 and that's the 6. Which is actually gone ahead and made that the 7 and that the 8. That the 6. Remember, this is actually a triple, so that's the 7. And likewise, that's actually a triple, so that's the 8. So we actually get sort of all of that filled in for us. Now, over here, we have a similar story. This needs a 7, 9, and the 7, 9 has to go here. No choice. So that is a 7, 9 pair. These 4 cells now need to contain a 3, a 4, and a 5, and a 6. And we know this one isn't a 5, 6. We know this one isn't a 3, 4. But the key point is that's 4 cells now that contain these 4 digits, 3, 4, 5, and 6. And so therefore these digits are 1, 2, and 9. We actually know. That one's not a 9 because it's got a 7, 9 looking at it, just for the record. But that does a few things. One thing is it takes 1, 2 out of both of these. Now, that's not horribly surprising if you were paying close attention and noticed that actually this 1, 2 quadruple always took 1, 2 out of that. But it is actually useful over here for what it's worth. But it does seem to make it so that these two now need to be 3, 5, because if they're not 3, 5, I just don't get a 3, 5 on this quadruple. Which makes those not 3, 5. Okay, now this 6, 8 quadruple, again, doesn't have the 6 and the 8 on it, so it needs to have a 6 and an 8 on it, and they need to go in this order so as to not break the world. Let's see, this 5, 7 quadruple definitely needs to have a 7 over here. I don't know about 5s yet. Oh, this is a 3, 4, 5, 6 quadruple in this row. I have just noticed. So therefore, that is not a 4. It is just a 1 or a 2. So one of these actually is a 4. I also noticed that this 7, 8 rules 7 and 8 out of these cells. In fact, actually, if I just look at this, where does the 8 go on this quadruple? Actually, by Sudoku, it can only go there. Now, where does the 7 go on this quadruple? By Sudoku, it only goes there. So we can fill in that over there. And so this row needs a 1, a 2, and a 9 in it. So I guess that means these are from 1 to 9. What else have we? Let's see, where are our quadruples that we have not fully exhausted yet? I know my 1 and 2 go down here somewhere. I do know the 4 is in one of these two cells, actually, because of this 2-4 quadruple. One of these two is 4. So none of those are 4. This one I know is not 5, just for the record, because there's a 5-7 quadruple here. Let's see. What else can we do? 2, 9. Oh, right. Where does the 2 go on this quadruple? We've got the 1, 2, 9 triple. It rules 2 out of those cells, so therefore that's a 2. Which makes these a 1, 9. Means the 2's up here somewhere. That 2 comes down here, means there's a 1, 4 down here. Let's see, what else is that going to give us? So there's the 3, 5, there's the 2, there's the 7, 8. Oh, there's a 5 or a 6 over here. Is this cell getting restricted? Let's see, what can it be? It's not 1, 2, 3, 4, 5. It's not 6, 7, or 8. Okay, yes, this cell is getting restricted because it can't be anything but 9. That seems fair. Okay. So that actually places the 9 there in this box. So we've got a 1, 2 pair here. Okay, so these are a 4 and a 6 or an 8 for the row. This is only 4 or 6. I don't know if I really want to mark that. I probably could, but okay, I know there's an 8 over here. Let's see. Do I know this isn't a 9? I don't know that's not a 9 right away. I still know there's a 2, 4 over there. One of those two is a 4. I know one of these two is a 6. Oh, I haven't corner marked that I know one of these two is a 7. That's probably worth marking. Ah, yes. One of those two is a 7, which tells me where the 7 goes in this box. Namely, the 7 in this box goes here. What are these cells? One of them's a 2. The other one could be a 4, but it can't be a 5. Can't be 6, 7, 8, or 9. Oh, these are just a 2, 4 pair. Is that what you're telling me? That is what you're telling me. Okay. I accept. So these are a 2, 4 pair. So that one's definitely not a 4. Oh, so this was just the 8 all along. Yeah, if I'd asked where the 8 went in this box, it would have been a lot nicer. I could have just placed it there. That would have been a much better way to do that than the way I actually did that. So these aren't 3, 5 because there's a 3, 5 looking down. And so this is not 1, 2, or 3. This just is a 4. And now we say there's a 2 on this, and that 2 has no choice but to be there. So we can do our 2 and our 1 like that, which now is going to back up and resolve that stuff back up there. Okay. Good talk. Okay, that places the 8 there. By sudoku. Let's see. I know there's a 5 in one of these two cells. Does that immediately do something for me? I don't think so. I'll mark it if I have to later. Let's see. What else can I say? One of those is a 7. I know one of these is a 9. This column has a lot going on. Oh, this is a 5, 7 pair, actually, because now those are a 1, 2 pair, so there's not a 5 here. So now these are a 5, 7 pair. There we go. And that's a 9, because I actually needed a 9 on this, so that 9 looks over there and gives me the 7 and the 9, which looks back and gives me the 5 and the 7. The 9 looks up. The 5 looks up. The 1 looks up. And then the 2 looks down, and then we've got the 3 and the 2, and then suddenly all of that got filled in real quick. We've got the 1, 2, 3, 4, 5, so this is just a 6. And then this is just a 3, I believe, which has filled in the 5 and the 3 over there, which fills in the 5 and the 3 over there. That 3 places itself in this box. Gives me a 3, 4 like that. Let's see. So now... so now this 2 looks down at this box and actually places the 2 over here. I was going to do something with corner marks, but I didn't need to be that sophisticated. I just place the 2 there, which gives me the 1 and the 2, which gives me the 4 and the 1 over there like that. And so now these 2 cells are a 1. In fact, actually, I was going to say, or a 1, 4 pair, but actually I can just place the 4 in this box here by sudoku, and then place the 1 in this box. I can place the 4 on this quadruple back over here. These 2 digits, one of them is a 3 and it's that one, and the other's a 5, which is that one. That is a 9 by the row. It's a 3 by the row. One of these is a 2. Oh, sorry, I should just look up here and finish that. One of these is a 2 by the row, and it's that one. And one of them is a 7, which is that one. We've sorted out the 5 and the 6 here in the middle over there. Okay, this column still needs a 6. So this column still needs a 5. This row needs a 7. This row needs an 8. This row needs a 1 and a 5. This row needs a 4 and a 6. And there we go. Alrighty, well, I hope you enjoyed that. I hope you gave this a try and learned something. The quadruples tend to be really good at practicing sort of the Sudoku mechanics. So naked and hidden pairs, triples, quadruples, in fact. So there was a lot of opportunity to sort of bounce that around to the grid and practice scanning for those, practice pencil marking those. So I hope you gave it a try. I hope you enjoyed it if you did. And I hope I'll see you soon on another Introduction to Puzzles. By the way, if you're enjoying this, why not subscribe? There's a button down below. You can even ring the bell icon if you want to be notified when these post. As well, I have playthroughs of a variety of puzzle games, most recently Lingo and Blueprints. So if you want to check those out, there's that as well. Also, partially the reason I'm doing this series is to get people sort of warmed up so they can follow the insanity that I stream a couple days a week. So if you'd like to check out those streams, those are on Tuesdays and Sundays at the moment, by all means, please come join us. We're always happy to have new folks in chat. Be sure to say hi and let us know if anything isn't clicking for you, and I'll be sure to explain it. Thanks for watching. Bye for now.